The essential question we want to answer in this video is, how does the value of A change the shape and direction of a quadratic graph? And as you're filling this out, class, I want you to pay special attention to these two words. Change the shape and direction. I want you to notice or think about this. The value of A does nothing to change the location of a graph. It does not determine where the vertex is going to be. What it does determine is how compressed or stretched a graph will be, that's the shape, and it determines whether it opens up or down, that's the direction of the graph. Now I'm going to go ahead and scroll through here. Let's talk about this table. You can see that this table has 4 different values of A. What is the transformation that's happening to the graph? Which way does the graph open? Is the vertex a maximum? Is it on top of the graph, or is it a minimum? Is it the bottom point on the graph? And then the last column here will show you is examples of a quadratic that has an A value of this particular value of A. So our first line is, what if A equals 1? Now you may have already graphed enough parabolas to recognize that when A equals 1, there's no transformation. It's not being stretched or compressed. It's a normal shape. Which way is the graph going to open? Well, a normal parabola with the A value equal to 1 opens up. The vertex, because it opens up, let's go ahead and sketch one of those and show you. Because it opens up, the vertex is the minimum point on the graph. And here's an example. F of x equals x squared. You can see the A value here is not written, so it means it has to equal 1. So here's a graph of A being equal to 1. This will not be stretched or compressed, and it will open up, and the vertex is a minimum. All right, let's go a little quicker through these. What if A is greater than 1? So if A gets big. As A gets big, the parabola gets stretched out. In fact, let's do this. I want you to do a little diagram in each of these. In this one, let's just kind of draw a shape that we figure is a kind of like a normal shape. When A is greater than 1, the parabola is going to get stretched. It's going to get thinner or pulled up. The graph still opens up because A is positive. So I'm going to put on here, let's put a little note here. This is a positive value of A. This is a positive value of A. That means the graph opens up. You know what? We shouldn't even write them there. We should write them, whoops, that's okay if I erase that. We should write them right here. A is positive. A is positive. And that means the vertex is a minimum. Here's an example of this. F of x equals 2 times x squared. Our A value is greater than 1. That means this parabola is going to face up, and it's going to be stretched. Okay? What about A being less than 1 but greater than 0? Remember, we've covered this before. If A equals 0 in a quadratic, that means the squared term is going to be 0 because you're multiplying by 0, and that means your graph's not going to be a parabola at all. It's going to be a line or linear. But what if A is greater than 0, but it doesn't get to 1, it's less than 1? Now our graph is going to get squished or compressed. The graph still opens up because A is positive. That means the vertex is a minimum. Here's an example of that. F of x equals 1/4 x squared. 1/4 is greater than 0 but less than 1. So there's a compressed graph. All right, let's continue on. Now let's look at our negative numbers. What if A is less than 0 but greater than -1? It looks a lot like this one, only now instead of a positive number, it's a negative number. So not only is this fractional value of A going to create a compressed graph, it's also going to reflect it or make it go upside down. So you're going to have a wide graph, but it's going to be upside down. The reason that the parabola faces down is because A is going to be negative. That means the vertex must be on top, which means it's a maximum. And here's an example. F of x equals negative 1/2 x squared. Negative 1/2 is the value of a. The negative means the parabola faces down or reflected. The 1/2 means the parabola is compressed. What about if a is less than negative 1? Well, now take a look at this. Now we got negative 2, negative 3, negative 4. It works the same way as if a is greater than 1, only now the numbers are getting more and more and more negative, and they're not fractional anymore. They're 2, 3, 4, negative 2, negative 3, negative 4. Now we're going to do the same thing as if a is greater than 1. We're going to stretch the parabola, only we're going to be stretching an upside down parabola. So it's stretched and reflected across the x-axis. The reason it faces down again is because a is going to be a negative number. That means the vertex must be on top. Here's an example. F of x equals negative 3x squared. You can figure, class, that if you had a negative 3x squared and then I showed you, I said, what's the graph going to look like negative 50x squared? You're going to say, oh, that's going to get so stretched out. You could barely see the inside of the parabola. It's going to be so stretched. The farther that number gets negative, or the bigger this number gets, the more stretched the parabola is going to be. And then what if a is equal to negative 1? Now all we have is a reflection. It's not a fraction. It's not between negative 1 and 0, so it's not going to be compressed. It's not less than negative 1, so it's not going to be stretched, so it's just going to be a reflection. There's no compression or stretch. It's just upside down, which means we're going to look like kind of like the normal shape. Down because a is still negative. That means the vertex is on top, or the maximum, and there is your possible function of x. F of x is equal to negative x squared. You can see that the a value is just negative 1. All right. Now, here's another way to do this. I want you to fill this out. I'll just pause. I won't talk about this too much, just showing you. Here's another way of writing this down so you can understand this. If a is 0, we've got a linear graph. As we move into negatives, between negative 1 and 0, the parabola faces down and it's squished or compressed. When we get to negative 1, we have our normal parent shape. It's just down. And then when we get farther down from negative 1, it still faces down, but now it's stretched. When we go the opposite direction, as the a value gets bigger and bigger and bigger, in this section right here, as long as it's less than 1, it's a squished or compressed graph, but it faces up. When it gets to be equal to 1, it's the same shape as the parent graph. And then when it gets to be greater than 1, it still faces up. They all face up over here, but now it is stretched. All right, so there are your ways that a affect the parabola. Let's do a couple examples here. And I'm going to need to do something real quick, class, because I cannot see this whole thing here. So give me 1 second. I'm going to move this. Give me a moment to make a correction here. All right, now we'll go back, and now we should be able to see it all. All right, let's do some examples. Here's a function, f of x equals x squared. Let's identify a. Well, a here is equal to 1. We know from the work that we just did that when a is equal to 1, the parabola faces up, and it's not stretched or compressed. So that means it's the parent shape. And in fact, we talk about the parent shape, I want you to know this is actually the parent graph. This parent graph, okay, the parent graph is going to be where the vertex is 0, 0, and the a value is equal to 1. That's what we talk about when we talk about the parent graph. I'm going to go ahead and draw that underline. Okay, the vertex is 0, 0. There is no h, there is no k, or in this case there's no b and no c, so that means that the vertex is 0, 0, and the a value is 1. This is our parent. This is the graph that's our normal graph that we compare every other graph to. when you plug in these values, when you plug in 0 here, 0 squared is 0, 1 squared is 1, 2 squared is 4. Let's plot those. 0, 0, 1, 1, 2, 4. Now you know, class, that we don't have to even plot the other 2 points because this is the vertex. That means the axis of symmetry is going to tell us that these points have to be reflections of the ones on the right. So we can graph the other points this way. And let's go ahead and draw our parabola. I will try to do that with my fast method. Again, it's not going to be perfect. You can do a better job on your paper, but good enough. There's our graph. All right, that's our parent graph. A is equal to 1, and there's vertex is 0, 0. What happens if A is equal to -1/2? So I'm going to say A here is -1/2. We should know from our table that if A is -1/2, that means negative. A is negative. That means our graph is going to be facing down. And since A is between 0 and -1, that means it's going to be compressed. It's a fraction that's less than -1, or in this case, sorry, greater than -1. It's a fractional value between 1 and 0, or in this case, between -1 and 0. That means it's going to be compressed. Plug in 0 here, you're going to get 0. Plug in 1, you're going to get negative 0.5. Plug in 2, you're going to get -2. Let's go ahead and graph those. I put the parent function on here for you now so you can see how it changes. So let's go ahead and do that. We got 0, 0. Negative at 1, it's -0.5. At 2, it's -2. We know that the axis of symmetry goes through the vertex. That means they're going to put 2 reflected points. There is our parabola. Let's try to draw that on there. See how well I can do on that. Close enough. And you can see now, class, compared to the parent shape, you can see this is getting stretched, it's getting compressed, it's getting squished, and it's going to get wider, faster. You can see how it only took 2 units this direction to go 2 units this direction. When you go 2 units up, it only went 1.5 units. So it's actually getting squished or wider. If you kept drawing this parabola, it would come way out here compared to the original. So it is definitely getting compressed. All right, let's do another one. What if f of x equals 2x squared? Well, our a value here is equal to 2. Since a is positive, we know our graph faces up. Since a is greater than 1, we know we're going to get a stretched graph. If you plug in your values for 0, you're going to get 0. For 1, you're going to get 2. And for 2, you're going to get 8. Let's plot that compared to the parent function, where a equals 1. We got a 0. 1, 2, you can already see it's getting narrower, and 2, 1, 2, 3, 4, 5, 6, 7, 8. Let's reflect those points on the other side of the y-axis, because the y-axis is the axis of symmetry. And let's go ahead and try to draw that parabola. And let's see what it's going to look like. You can see, even though I'm not terribly accurate, I can see that I've got some. Let me try this here real quick. I don't know what it's going to do. Let's try stretching that out and moving this one in. Oh, we can get a little more accurate. All right. That's not terrible. We'll go ahead and put some arrows on it. And you can see, based on compared to the parent graph, this is definitely getting narrower or getting stretched. So an a value greater than 1 stretched the parabola or pulled it up and down. All right, one more thing I want to add here. If you go over to here, this might help you a little bit in this section. Let's go ahead and draw this, this example. If it's here, it's going to be stretched and down. Here it's going to be normal shape but down. Here it's going to be compressed but down. Here is linear. Here it's going to be compressed and up. Here it's going to be normal parent graph and up. And here it's going to be stretched and up. So you can see kind of what happens to the graph as the A value goes from really, really negative all the way to 0 and then back up to really, really positive.